still working on moving our parent functions all over the place. Today what we're going to be looking on is I can graph reflections of functions and write the algebraic equations of the reflections of the functions. Okay, it's kind of a mouthful there. Okay, so first of all, we're going to be examining different kind of reflections. And the first one we're going to be examining is a reflection over the x-axis. Now you've done this already before with parabolas. Now, if you print it in grayscale, you might want to take a pencil crayon so that you can tell the difference between the original function of f at x and then its reflection. So really what we're doing here is a reflection over the x-axis means it's a mirror image through the x-axis. So it's like taking that x-axis and folding it over, and that becomes our reflection. So if the original parent function is f at x, the reflection over the x-axis is the new function negative f at x. Okay, you've seen this before when you've reflected parabolas. Okay, but it can work for any function. All right, and we're going to talk about how we actually do that with graphs in a moment. Okay, the other kind of reflection that we're interested in is reflecting over the y-axis. Now, this is something you haven't done. So for instance, again, if I look at my original function f at x, okay, it's a kind of a crazy one. And if I want to reflect it over the y-axis, it is like taking along the y-axis and folding it over. Okay, so if the original parent function was f at x, the reflection over the y-axis is going to be f at negative x. So what happens is the values change. So if I look at the difference between the two, okay, if I'm reflecting through the x-axis, what happens is the original point at xy becomes x negative y. So it changes the y value. On the other hand, if I'm reflecting over the y-axis, if my original point was xy, then my new point is going to be, here we go, negative xy. Okay, so that's going to be important for us on the next page. Okay, now it is possible that we can combine both of these. Sometimes we call this origin symmetry. So what's happening is we're reflecting our points not only through the x-axis, but also through the y-axis. So this is how it's written, f at x, and what we're doing with our translation, it's going to be negative f at negative x. So again, what's happening, if I have a point xy, it becomes negative x, negative y. So it changes both of our values of our coordinates. So let's take a look at what that means when it comes to graphing. Okay, so I have my first graph, and first of all, it says to sketch g of x. So I'm starting with f at x, and f at x is 1 over x plus 1 plus 3, and they're telling me g of x is going to be negative f at x. So what that means, a couple different things. First of all, I have to understand what parent this one comes from in order to then be able to translate it. Okay, so we know this is our reciprocal function. We know that it has asymptotes. And this one, because of the translation, we know that the x value of the asymptote here would be at -1. And so I'm just going to put that so we have it. And we also have the other ones at +3. Okay, and then from that, we know a few different things. We know some points specifically on this f at x function, because we know where they intersect becomes the point over 1, up 1. Okay, and that point is actually 0, 4. And so I'm actually going to write that beside it because that might come in handy to us. So 0, 4. And we know that we go to the left 1, down 1, and so we know that point is going to be 2, 2. So I'm just going to write those down because that's going to be important for us. Okay, and then we know that we would do our creeping. Now what we're going to do is when we're talking about graphing g of x, now if we remember from our previous page, what happened to those points, oops, and it disappeared from us, we know that the x remains the same number, but the y changes sign. So that's what we need to do. So our points that we do know have to do with the following. So if we actually go and take a look at that, so we're going to write that down so it makes our life a little bit easier. So we know, first of all, I'll bring up my green. So we know that if we have a point x, y, we know that it's going to be moved to x negative y. And that's going to be true also of our of our asymptotes. But let's first of all look at the points we do know. So we know we have a point 0, 4. And so according to that, that means that that would be translated into, reflected into 0, negative 4. We also have the point 2, 2. So we know that that's going to be transferred to negative 2. So we have our two points that have been translated, and so let's actually go and actually put those on. So we know we have at 0, 4, negative 4, so that's going to be here, and our other point is at 2. Oh, sorry, should have been negative 2 here. No one's, I'm sure all of you caught that. Negative 2. So that should be, then our new point should be at negative 2, negative 2. So here is 2, negative 2. Okay, so those are those points that we had up here. Now they've been translated. So what does that mean as far as our asymptote lines? Well, according to this information that we have here, and I'm just going to bring out this part here, the x asymptote would not change. So the x asymptote remains where it is, which is in this case at negative 1. The y asymptote, however, flips to the negative value. So let's go and do that. And I'm going to change colors of my line if I can. I'm going to do it in this color and then I'll change it. So it's telling us that this one's going to stay the same. And my y1, which at the moment went through positive 3, is now going to go through negative 3. Okay, so you can see it kind of gets a little bit messy with all the different graphing stuff that goes along. Now, as I said, I'm just going to change mine a little bit so that it is a little bit easier on the eyes to see. And we need to have arrows put on the ends. And I'll do the same thing with the vertical one. Do red and arrows. Okay, so now what's happened here, other than that line shouldn't be there, we have our points and we have our asymptote lines, so it's just a matter now of drawing our graph. And I'm going to draw it in actually black to make life a little bit easier. So it creeps along, it must go through the point 0, negative 4, and it creeps along and goes through the point negative 2, negative 2. Okay, so that is that graph. Now, because it gets quite messy, we need to also label our graphs. So this last one that we did, we know is g of x. So we're going to actually put that this is g of x, and it wouldn't hurt to put that the green one was f at x. All right, so let's go on to the next example. Okay, the next example, when I look at it, again, what's happened here is we have the square root function, and I know the square root function has the point 0, 0 normally, but it's been translated up, so 1, 2, 3, and then it goes over 1, up 1, over 4, up 2, so 1, 2. Okay, so that is our f at x in this case. And we'll actually call it f at x. And then our next one tells us what they want us to do. Okay, so now in this case, they want us to take the function f at x, and we're going to replace some of the values here. Now, if I go back to our first page and we talked about reflection over the y-axis, and what happens there with our points is when we find it, we have the y remains the same, but the x becomes negative. So that's what we're going to do here. So we know that if I have f at x, that when we're talking about reflection, it's going to be negative x, y. So now let's go over to our graph. I think we can do that. You can either write it down like this if you want, or you can actually translate it. Okay, so if we look at 0, 3, well, if I change the x value, it's still going to, like, change its sign, it's still going to be 0, 3. Then if we look at this point here is 1, 4. So that means I'm going to go negative 1, 4. This point here was 4, 5. So this one's going to be negative 4, 5. Okay, and again, we're just going to draw our line through there, nice curve, and this becomes g of x. Oops, that's a really crappy x. Okay, so that gives you an idea. It's not that bad after we get going. And let's see if we can get another one done here. Okay, this time I know I have a parabola, and I actually will draw this parabola in black, our regular one. So I have a vertex at 2, negative 3. So 2, negative 3. It has no stretches or shrinks, so over 1, up 1, over 2, up 4, 1, 2, 3, 4. And then it's a matter of reflecting that through its axis of symmetry, and this is my f at x. Put arrows on it. And now it's a matter of looking at g of x. Now in this case, you can go back to your first page if you want, but if I'm starting with, sorry, that looks like crap. I'm starting with xy. What happens is it's going to be reflected into both the x-axis and the y-axis. So it's going to take all the values and change all of their signs. So if we want, we can look at this. We could, I think what I'll do with this one, since we have 3 of them. So the one point, our vertex was 2, negative 3. So that's going to translate into negative 2, positive 3. The point 3, negative 2 will be translated into negative 3, positive 2. And finally, that other point was 4, 1. And so that's going to be translated into negative 4, negative 1. And we're going to change colors here and actually draw our g of x now. So negative 2, positive 3. Okay, now this is like our new vertex. Then we have negative 3, positive 2, and then we have negative 4, negative 1. Okay, and so that's the one half of the parabola, so that's this arm of it. So we can get the other arm by the symmetrical property. Okay, and again, we want to draw a nice smooth curve, and I'm drawing mine with a mouse, so it's not necessarily smooth. And so this becomes our g of x.